Hi folks, happy April. We have a bunch of shop updates that I'm really excited to share with you guys. Everything from new machines that we've already bought, machines that were bought and are soon to arrive, some machines that we're selling. Robots are a big theme, and some software, quality of life, AI, things that we've learned and made and so forth. So, wanted to dive right in. I'm going to start with the one that is just feels awesome, Johnny 5. We started building Johnny 5 probably about 7 years ago. Put about 3 years of work into him, got burned out, reached out to the internet, to you guys, and we had hundreds of people make small parts or big parts here and there, and really were able to get him to a pretty good mechanical standpoint, but very little of the electronics was actually done or working. And we took about a 3 or 4 year break between the business growing, COVID, all that stuff. And about 1.5 years ago, I dusted him off and said, no, let's do him justice. And so the team at Input Inc., that is the organization that's really responsible for a lot of the CAD and design and so forth, had also made a number of improvements. So we ended up breaking him, disassembling him all the way back down to every little part. And we rebuilt him, and he is not done. To some extent, he'll never be done. But look, take a look. I mean, this is awesome. Almost every single motor, joint, actuator, cable, servo, mechanism works. They don't necessarily all work at the same time, and I've got some, for sure I've got some electrical gremlins I've got to sort out, but still feels awesome to see him in this standpoint. And one more fun share, last week was 10 years in this shop. When we first moved in, I had been in about 1,000 square feet for about 8 or 9 years, doing this mostly as a hobby, but then professionally or whatever, full time. And we moved into this shop, which is about 10 times bigger, and it felt like a sea of space. And now you can see we're now actually far more conscious of how we put what machines and where, so that we make good use of the space. We've used this 3D print model for years, continues to be really helpful. We have the floor joints shown so we can actually space machines out and choose whether we want to stay inside of a crack or if we want to span a crack. And this will quickly tell you what's happening. We are adding a second Okuma Genos M660. That's to help with our steel plate production volumes. That's going to probably go right where this VF6A is. That machine has already been sold. We are replacing or adding a Doosan DNM 6700. It also arrives in about 2 weeks. It'll go here for some time. VF6B, VF6, the other one, will go probably right where we're standing for a short period of time, but eventually it'll be cycled out. We're producing so many more steel plates, and we used to have 2 machines dedicated to aluminum. Now we really need 2 machines dedicated to steel, and the M660s have just been absolutely bulletproof. We actually sort of shout out, we looked at a Takumi machine pretty seriously at Bridge Mill, but it just wasn't the right fit, and the Genesis, we know that machine, so that's great. So we're selling VF6B, and we're also selling our horizontal, our MB4000H. It's been an absolute great machine. We're still using it every day. In fact, you can see that it's running right now. It has the 6 pallet pull option, the 218 tool changer, all the good options of probing, through spindle coolant, etc. But I'll show you why we're selling it here in a second. Short answer, robots. So if you are interested in either of those machines, pricing, specs, details in the link below on our website, but robots are our answer. The horizontal is incredible. We love it. Like I said, it's still running. We wouldn't have been able to build the business to where we were today, but we're now a pretty focused product company. We know certain parts, certain sizes, and production volumes. And what this robot system lets us do, this is a Brother S700, basically a totally normal Brother. It's the high torque version, so it has the 10,000 RPM higher torque spindle versus the quote-unquote normal machine is, I believe, a 16 or now 20,000 RPM spindle. But otherwise, that's normal. We added an auto door to it, which might work right now. Yeah, there you go. We'll do a whole build video on that too, by the way. but that opens and closes the door, maybe. I think I have to wait. There it goes. But then the real magic here is this UR10 robot system that we sort of put together half ourselves or a third ourselves and the rest from Lights Out Manufacturing, which is an integrator that we first saw at IMTS. They have a really cool, modular system that helps these work in a environment where you may run in different part sizes. We're not doing that. We're just running basically one part size, although not really. But basically, we can now, what the system does that's so different than the horizontal would be take a part like this. Right now, we make these 4 at a time, or 8 at a time, or even 16 at a time on the horizontal. But every time we want to make one of those, there has to be a part loaded and unloaded. Usually that's at least 1 screw or actuation, maybe 2. And it takes a fair amount of time to do so. This is a one-piece flow system, so it only runs one part at a time. But we can take this part, and to load the machine, you're done. You can stack those up 4 or 5 high, and there's 25 spots, so you can do the math. Fairly easy to get over 100 parts. We don't really need more than that because you start to hit the 24 or even 48-hour run time. So this will be able to make those prismatic parts. But then what I'm really proud of, and this is already running, I'll splice in a bunch of B-roll footage throughout the days of it running. We also wanted it to run these round parts. So we 3D printed these inserts. That way we don't have to remove any of our L brackets, and they allow us to drop on these 3-inch slugs, and that's what's in here right now, where these Kurt vices have these robo wrenches, on each end. So the robot or the integration system can open and close each vise. We also have added a bunch of steel or stainless steel guarding that we did from Sencut Sen, which has really helped the robustness of this. And so in this example, it's able to run up 1 and up 2 of these round parts, and without changing any of the tools or really anything on the robot, but just these inserts on the jaw, we can then switch to our square or rectangular parts. It's been absolutely awesome, and if you actually sit down and do the math, a machine like this can actually blow a horizontal out of the water because it's so easy to keep it fed, and you have almost no time on the daily loading and unloading of the material. And you also can scale production and volume without having to invest in fixtures, but it's not even investing in the fixtures, it's that quirkiness around, how do I probe them, or is one different, did one goof, and so I need to either repair it or skip it, all those sorts of things. So I'd say we're probably still in the 3rd inning. The machine's been running for about a month, it's made lots of different parts, it's been run quite well, but we're still running it mostly during the day shift, unattended. We'll start, we've got a bunch of different milestones that we want to sort of hit before we start pushing into the evening and then ultimately sort of lights out, if you will. We also put our Sencut Sen chip pan up on the Sencut Sen makerspace place, I think it's called. So if anybody wants to order that, they can. And then there's a maker pipe. We included the fusion model there. What it does is it holds the chip bucket at dual angles, and then here we have a bucket on the ground, but back on the Genos, if we walk back, I'll show you the bucket can actually hang from it. It just helps with a hole drill in there. It helps the chips allow them to sit and the coolant can drain out. And you can either strain that, discard it, recycle it, or if you want, you could just pour it straight back in. Here's one of our, this is a plate set that is shows our bubble edge, where these bubble edges will mesh together. It just looks beautiful when they go together. We used to have a coolant shield for our grinder that was mounted, designed very poorly by yours truly. It was mounted with a linear rail or one of these, guide rails on the bottom, and it just was always a fussy mess. And it finally kind of broke, and I realized I had really gone about that quite stupidly. So I mocked this up real quick, where instead we have some 3D printed cleats. This will obviously get all finished, but for now, bolted in here. And then we had 3 pieces of Lexan cut from Sencut Sen. Some trucks on here, and then the idea is we'll have some magnets that'll kind of lock this in place, because this whole top is moving back and forth quite quickly when it's grinding, so this door will slide all around. But I want a hassle-free way to open it, so having a magnet system here will lock it in place, but it means you can just open it anytime you want and close it. We've got one of our interns working on that right now to kind of finish it and bring that home, but it's both really nice. I think it should be much more stable system. And over the months or years, if we need to replace these Lexan, we just order a new part, screw a couple pieces out, and replace them like so. The other quality of life improvement that might be even better is we have a UMC-400, and it was quite annoyingly, it would drip coolant out of these nozzles after you turn the coolant off, and you'll see that that has now been fixed. See, we can do this without getting wet. So now you turn the coolant off, and it stops. That one dripped a little bit, but you can see it's pretty much stopped. It used to dribble for about 20 or 30 seconds. If you guys are watching Run Machine Shops, you probably know. Not only is that really annoying, but it means you get your hands wet, your part keeps getting wet after you burn it off, you get your calipers wet. And all we did, somewhat counterintuitive to me, to be totally candid, is we added a one-way check valve. I'll put the McMaster part number in the video description. And the counterintuitive part is it's a one-way valve that of course flows this way, but it has a ball and a spring in there such that until there's enough pressure to force the fluid out, unless there is, then it sort of seals it back up, which is what helps stop that drip. I mentioned the theme of the video is robots, so we, again, are really, really happy. We plan on adding another machine like that brother, and then we also plan on adding a robot to this UMC, which will probably live right over here if I have to move the printer, but we've already got the door from Haas on that. And actually, Grant helped design this really cool prototype. When we produced our top jaws, oftentimes there's a burr on the inside lip, and it just has to do with the way we produce them. And we used to hand Scotch-Brite that off, but now we've got a system, I'll splice the footage in here, where it's going to be able to drag that part through a jig. It'll knock that burr off. We'll probably add either a stone or something like a sprung piece of Scotch-Brite or even a Scotch-Brite wheel. But that's what I'm really excited for, and I mentioned we have some sort of phases of how we're going to bring this automation online. We've already got it working. The next step is then how do we improve the in-feed, and how do we do more with the robots when the parts come off. They can be deburred, they can be demagnetized, they can be degreased, they can even be assembled or put into boxes. Really, really cool. But I also want to show off, this is an actual legitimately awesome use of AI. Grant is obviously very capable as a machinist and even might be modifying post-processors, but said kindly, you're not a software developer.
No.
Had you ever written a program or website, web app before?
No.
And you got this indicator from Precision Metrology, right?
I think so.
Okay. So you want to show us what we're doing here?
Yeah, so we have these fixture pins right here that we manufacture, and we want to try to get the robot to load them eventually with this linear rail right here. But right now we got it measuring, and all I got to do is click the side button here, and this sends data to the computer, which logs it into our web-based app that I built with Claude. And over here you can see this is our tolerance. So there's a low end tolerance that we can adjust, the high end, nominal, and then this is all of our auto offset info. So this is what sends it to the machine. And for now, we can hit apply now. And then it shows the changes that it sends to the machine. And Claude also helped build in auto correction if we want to, which will be in the future.
So to recap, we have a USB connected to a digital metrology tool. We can log the data, and then if you want to, you can click a button and it pushes it via the FANUC Focus 2 interface to the Williman to update to offsets.
Yep.
So what I love about that is, number one, we did it. In fact, Grant didn't even talk to me about this. He spent a couple of days while he was doing other stuff noodling on this, but it wasn't one of those things where we sat down and decided to pursue a project and scope it out. You just did it.
Yeah. Yeah, so you can see here on the variable, it writes to variable number 800, and right there is the change that we made. Incredible. And for the Williman, we can use a G code to write that variable to the tool offset before it brings the tool up.
Any advice for folks that are watching about doing this sort of stuff with AI?
Just take your time with it and make sure everything's right, and just have the ideas, because you can do anything. It seems like you can do anything you want with it as long as you have the ideas.
What made you think of this?
Honestly, we've been talking about changing up our QC of our fixturing pins, and I always kind of wanted a way to log it, and it's just nice that I thought of an idea that I wanted it to be, but I didn't know how to make that happen, and I just asked Claude, and then it came up with all this stuff for me, and going back and forth with Claude for a couple days in between running everything else. I came up with a web-based app and a way to send it to the machine.
Dude, awesome job.
Thank you.
I think that's my takeaway, and look, we're all different, but as a 42-year-old, I overthink stuff, and sometimes with AI and these LLMs, you just have to start a conversation and just sort of free your mind of the limitations that many of us who have spent 20 years in the workforce feel like we have, and I give Grant a lot of credit. You know, the goal here would be a robotic way to take each part off and measure and log each one. So break that down. What do I want to do? I want to measure a part. We need a digital tool. We want to log that data, and so on and so on. I love the fact that this was so easily able to be done, and we'll see where we go with it. A couple of software quality of life updates. We had a few Fusion projects that had a ton of files, and I couldn't figure out how to bulk move all of those. And I realized I knew I needed to be in the website version of Fusion, which we're showing off here, but the trick is to move into the sort of right-hand window, and then you can bulk select and bulk move. It does take a minute. It's not particularly snappy, but happy to pay that price of being a little bit slow if it means I can select 20 or 30 or 100 projects and immediately move them all. The other really cool thing is what's happening over at Toolpath. Toolpath is all about AI cam, so taking apart and sort of automatically programming it in Fusion. It ends up there's a ton of things that are involved in that actually happening, one of which is what tools to use, and they have what's called the Tool Recommendation Engine. So I'm uploading this Johnny 5 hand part right here, and there are two tools that it needs to have, at least if it wants to machine it in this orientation. It needs a woodruff cutter, and it needs a small drill, and I think it also needs a small radius bull nose to technically be able to fit that rad. Now, of course, you can surface things in and sort of cheat, if you will, but what's incredible to me about what they've built is the ability to take a part or step file like this and pretty quickly, and for, I think, free, you have to pay, I think, to have the CAM side of it, but the TRE, I think, is publicly facing. It can just immediately tell you, oh, you can run this job with your tool library, except you need to buy this Kennametal end mill or bullnose or Harvey key seat cutter, et cetera, et cetera. Really, not only cool today, but cool to see what hopefully is going to come from that for the ability to quote jobs quickly. I say program them. I want it to help me program them, but I actually like programming them. I don't necessarily want software that takes that over, but it would be nice if it could do most of the work, and it lets me kind of finish up some decisions. Curious to see what you guys think about that. I'm guessing if you're watching this video and you're a machinist, you actually like programming in Fusion, you probably just wish you were more efficient. And lastly, shout out to my buddy Amish over at SS CAD/CAM. He had picked up this new 3D microscope, relatively inexpensive, I think a few $100. And I wasn't exactly sure, sort of 3D in a stretch of the imagination. It's really just able to take an angled view of your part, but I was looking for a new microscope anyways. It included this tool arm, and it actually is pretty cool. You can look straight down in your part in the traditional way, but if you rotate that angle back, you get this sort of like side angle view or bird's eye type view looking at an angled view of your part, which can really help with that depth perception. As always, folks, though, I enjoy sharing this story with you. It's crazy to think we've been in the shop for 10 years. It's going to be an exciting few weeks with some machines coming in and some moving out. But as always, folks, hope you learned something. Hope you enjoyed. Take care. See you soon.